Good morning, students. In this video, we are going to discuss about the Module 1 Transport Layer Security. Under this security, we are going to discuss an secured socket layer, and we will see the overview of the secured socket layer. Today, we are going to discuss in this video about the cryptographic assurance in the secure socket layer, SSL architecture, the concepts, record protocols and its operations, record formats, and we are going to discuss finally a protocol payloads of SSL. What actually a secured socket layer SSL is? Let's see about a secured socket layer in detail. One of the most widely used security service in the secured socket layer and the follow-on internet standard known as and transport level security TLS, the latest defined in RFC 5246. A secured socket layer SSL is a general purpose service implemented as a set of protocols that rely on TCP. At this level, there are two implementation choices for fully generality. SSL or TLS could be provided as part of the underlying protocol suite and therefore be transparent to applications. Alternatively, SSL can be embedded in specific packages. For example, most browsers come equipped with SSL, and most web servers have implemented the protocol. This SSL, Secure Socket Layer, implements three cryptographic assurances. The first one is authentication, second confidentiality, and third integrity, data integrity or message integrity. Also provides a secure key exchange between a browser and server, and provides a secure parameter negotiation, and it does not offer an non-repudiation. Let us see about an SSL architecture. What actually an SSL architecture is? If you're going to see about this, a protocol stack has been shown over there, SSL protocol stack. And SSL is designed to make use of TCP to provide a reliable end-to-end a secure service. SSL is not a single protocol, but rather a two-layer of protocols. As illustrated, you can see in the particular diagram, the SSL protocol. The SSL protocol provides basic security services to various higher protocols, in particular the HTTP transfer protocol, which provides the transfer service of web client or web security or web server interaction, can operate on top of SSL. Three higher layer protocols are defined as a part of SSL: the handshake protocol, the chain cipher specific protocol, and the alert protocol. This SSL specific protocols are used in the management of SSL exchanges and are explained. We will see those things in the later. And two different SSL concepts that are an SSL concepts are called as an SSL session and SSL connection, which are different in the specifications. Let's see one by one. What actually an SSL connection? A connection is a transport that provides a suitable type of service for a SSL. Such connections are peer-to-peer relationships. These connections are transient, and every connection is associated with one session. And a session, SSL session. A session is an association between a client and a server. Sessions are created by handshake protocols. Sessions define a set of cryptographic security parameters which can be shared among multiple connections. Sessions are used to avoid the expensive negotiations of new security parameters for each connection. Between any pair of parties, applications such as HTTP on a client and server, there may be multiple secure connections. In theory, generally, if you're going to see about, there may also be multiple simultaneous sessions between parties, but this feature is not used in the practice. There are a number of states associated with each session. Once a session is established, there is a current operation state for both read and write, that is for receive and send. In addition, during the handshake protocol, a pending read and write states are created. Upon successful conclusion of the handshake protocol, the pending state become the current state. As we are going to see about the session and connection in detail, a session state is defined by the following parameters. We can see about the first one, session identifier. It is an arbitrary byte sequence chosen by the server to identify and active or resemble session state. Next one, appear certificate. Appear certificate is nothing but an X505 version 3 certificate of the peer. This element of the state may be null. A third one, a comparison or compression method. The compression method, this algorithm is used to compress the data prior to the encryption. The fourth one is cipher specification. This specifies the bulk data encryption algorithm such as null, AES, etc., and an hash algorithm such as MD5 or SHA1 used for a MAC calculation. It also defines cryptographic attributes such as the hash size. Next one, master secret. Master secret in generally it's a 48 byte secret shared between the client and the server and is resemble. A flag indicates whether the session can be used to initiate a new connection or not. These are the 6 parameters of a session state. Let's see about the connection state. A connection state which consisting of the following parameters. The first one, server and client random. The server and client random, which has a byte sequence that are chosen by the server and client for each connection. Next one, a server write MAC secret. The secret key used in MAC operations on data sent by the server. The client write MAC secret, which is the secret key which have been used in the MAC operation on data sent by the client. Then fourth one, secret key writing. So server write key. The secret encryption key for data encrypted by the server and decrypted by the client. Then fifth one, client write key. The symmetric encryption key for data encrypted by the client and decrypted by the server. Then the sixth one, initiation vector. When a block cipher in CBC mode is used, an initialization vector IV is maintained for each key. This field is the first initiated by the SSL handshake protocol. Thereafter, the final cipher text block from each record is preserved for use of the IV value, nothing but the initialization vector value with the following record. The last one of the parameter of the connection state is sequence number. Each party maintains a separate sequence number for transmitted and received messages from each connection. When a party sends or receives a change cipher specification message, the approximate or appropriate sequence number is set to 0. Our sequence numbers may not exceed to the power of 64 minus 1.